All right. Let's say your birthday is coming up and somebody gets you a gift. Okay. Or let's say they don't get you a gift, they give you some money. All right. With that money, and you don't have to write this down, but with that money, let's say you go out and buy, gosh, what do kids go out and buy these days? It used to be like CDs but we don't have CDs anymore. Not everybody's into gaming. Let's say you go out and buy a shirt, okay? And you just take it off the rack. You don't try it on. Well, you get it home and you try it on, and it really just doesn't look like you, doesn't fit quite right, okay? Wasn't really what you thought it was going to do. So, what are you going to do with that shirt? Are you going to keep it since you spent your hard earned money from your birthday? No. What are we going to do with that shirt? Hopefully, you're going to return it, right? So, you're going to take that shirt back to the store where you got it, and what are you going to get for that shirt? Money. You're going to get your money back. Okay? This is what we call an inverse relationship. Okay? An inverse relationship where you take something and it leads you to one thing, and then you start with that second thing, and if you go that route, it will lead you back to the original. All right? That's an inverse relationship. So let's take a look down kind of in this middle section. It says example right here. So let f of x be x minus 5, and its inverse is f, or the inverse of f of x is x plus 5. Okay, so this is what we call an inverse. So it says evaluate with the function where x is equal to 7. So you are going to substitute 7 in place of x. So the function of x is x minus 5, and when x is 7, 7 takes its place, and we get 7 minus 5, which is equal to 2. All right, so we get 2. Now, if I substitute that 2 into that function's inverse, and they already told us what the inverse was, then that means I substitute 2 in for x, and 2 plus 5 gives me 7. So because I'm going back and forth between those two numbers, when I substitute the 2 and that gives me 7, and then when I substitute the 7 in, it gives me 2, we say that those two functions are inverses. Okay? So I want you to write down here, over to the right, the inverse function notation. Inverse function notation looks like this. You might have f of x here, and then if it's an inverse, you're going to have a little -1 in between those two, raised up just a little bit. So that means that's the inverse function. Okay? Inverse functions. All right, so inverse functions are functions that are inverse of each other. Okay? Where x and y are switched. We are literally going to switch the places of the x and the y. Sometimes it will be the x values and the y values. Sometimes it literally will be the x and the y. Okay? Inverse function notation. I guess I could have put that right there. So this is f to the -1 of x, which is the inverse function of x. It says at x, but usually we say of x. Okay? So there are 3 ways of finding inverses. If you have a table, let's say you have a table of x values and f of x values. Okay? So your x values are just your x's. The f of x value is kind of like the rule, or another way of saying a y. All right? So when you have this table, you are literally going to swap all x values to be the inverse in that function f. So the inverse function of f and the f of x values will become your x values. Okay? So the x and the f of x values, you're going to swap all the x values to be your inverse function of x, and your f of x function values will become the x's. So I'm going to jump down right now to where this table is instead of doing each one of these. Okay? So let's jump. Did everybody get that written down like they wanted? Let's jump now to the next page where we actually have these tables so we can talk about them. All right, so here I have my x values. Here I have my f of x values. The f of x really just is your y value. Now you're like, well, why didn't they just say x and y? Well, because they're talking about it in the way of a function. So if we want to find the inverse of these tables, all of these x values are going to become over on this side. They become the inverse function of x. So now -2 is showing the inverse function. Then we have 0. Then we have 2. And then we have 4. And then everything that was the f of x value, which is your y value, literally becomes your x value. So this is -4, -3, -2, and -1. So you are literally swapping, okay, you're swapping your x values to be the inverse function of x, and you are swapping the y values to be your x values. Okay? So letter B, go ahead and see if you can find the inverses of this table. Find the inverses of that table. Go ahead and see if you can do that. I bet you can. I know, you're like, what's the point? Well, there are 3 different ways to do it. This is just one. All right, hopefully you've got a good start, but here are my x values. I want to find the inverse from this table. So the x values are going to go now to the inverse function of x values. So that means I have -1, 0, 1, and 2. What were my f of x values, which is just the y, is now going to become the inverse by changing to the x value. So that's -3, -1, 1, and 3. Any questions about that? Okay. All right, let's go back now, flip back to the last page. Let's talk about equations. So this is back on page 7. So to find the inverse when it comes to equations, you will, I'm going to say swap. Are you guys familiar with the word swap? Replace one with exactly the other? Yeah. So we are going to swap the x with the y variable in your equation. You are literally going to swap the x with the y variable. So, example, let me give you a quick example. EG means example. So if I have y equals, actually it's probably not going to say that. It's probably going to say f of x, first of all. And it's going to say f of x equals 3x plus 2. You initially, because this is y, you are going to swap out the x and the y. So now you're going to say x is equal to 3y plus 2. So you swap the x with the y variable, and then I should have added, and then solve for y. Okay? Because we don't usually see these linear equations as x equals. We usually see them as y equals mx plus b form, right? So you swap the x and the y. No swapping of numbers here yet. And then you have to solve for y. Might want to underline that. So it's not just swapping the x with the y. So let's see if we can find equations where we talk about that. Okay, I need to come back to that. Go to the top of page 9. So the top of page 9 says we want to find the inverse of this function. So f of x, another way to write that is just to call it y. All right? So we're going to rewrite that function instead of the f of x. We're just going to say y equals 3x minus 6. That's how we rewrite it. Okay? Step 2, we are going to exchange or swap the x and the y. So your new equation is going to say x equals 3 times y minus 6. Okay? X equals 3 times y minus 6. Then it says we have to solve for y. So we want to get this y by itself. Well, on the same side with that y, I have 3y minus 6. So how do I undo that subtraction of 6? What would I do? I need to add 6. So let's add 6. And let's add 6 on the other side of the equal sign. The 6's over here are going to cancel out, and I am left with 3y on the right-hand side equals x plus 6. Are those like terms? Can I combine those? No. So I'm going to leave it as x plus 6. But wait, I'm trying to get y by itself. So right now we are multiplying 3 by y. To undo that, I would need to do the opposite and divide. So we divide. Your 3's are going to simplify out, and we get y is equal to x plus 6 divided by 3. Now, that is one way to show it, but we kind of want to put this in. Remember, we want to put this in y equals mx plus b form. And you're looking at it like that, and you're like, I'm not really sure about that. Well, what is my number? What is my number, Ashley, that really is in front of that x? Hold on. Okay. What is the number that is in front of that x? Please put that down. Do you know? Who can help her out? What's in front of the x there? It's a 1. So really, that is part of a fraction. If I look at this, I end up getting 1/3 times x, right? Okay. Then as I look at the second one, it's plus, and when I take 6 divided by 3, that gives me 2. So now I have it in that y equals mx plus b form. My slope is 1/3. That's the part in front of the x. And the y-intercept is 2. So that's kind of a blast from the past. Finally, it says over here, replace y with the inverse function of x. So if I'm looking at this right here, I would need to change it and say the inverse function of x is equal to 1/3 x plus 2. All right, so then we just need to graph. So if I look up at the very first thing we did, we had y equals 3x minus 6. That's up at the top. All right, I know it's been a while since we've done some graphing, but we have here a slope that is 3, and we have a y-intercept that is -6. So you always start with the y-intercept right here, -6. That's going to be on your y-axis. So 1, 2, 3, 4, 5, 6. That is just off the graph. And then your slope, if it's a whole number, you can always put that over 1. So this means you are going up 3 because that's a +3, and to the right 1. So from that point, we are going up 3, 1, 2, 3, to the right 1. Up 3, 1, 2, 3, to the right 1. Up 3 over 1. And you're going to put a line with the arrows on the ends. Okay? So that was my original equation. Then we worked through and we found its inverse. And that inverse is 1/3 x plus 2. So my y-intercept for the inverse is 2. So I'm going to put 2 is where I start. And then for the slope over here, That means I am going up 1 and to the right 3. So from that point, up 1 to the right 3. 1, 2, 3. So they actually intersect at that point. Up 1 to the right 3. And if you want to go backwards, instead of up 1, right 3, you would do the opposite. Down 1, left 3. Down 1, left 3. And we want to connect those points. And you have then, in the blue line, that is the original graph. And the green line would be its inverse. Okay? Any questions about that? Since we are talking about inverses, there is a single line called the line of reflection that would show these as inverses. So if I start here at 0, 0, 1, 1, 2, 2, and if I drew this line, kind of like a dashed line in here, that is the line y equals x. That is my line of reflection, because if I took a piece of paper and folded along that line, you would have these two lines, those two graphs, line up one on top of the other. That's how you can tell you have inverses. Okay? All right. Okay, we'll check that one in a minute. Let's go back. Well, we kind of did the graphing there. I'm gonna go back to example 1. So go to page 8. I know I'm kind of jumping all around, but I thought after talking about each one, we would actually do that particular type of problem. All right, so example 1 says find an inverse relationship. So this again is very similar to your table. So here you are going to swap or switch all x values to be the y values, and all the y values are going to switch to be your x values. Okay? So instead of, we have this point A, which is 2, 4. So if I'm going to switch that out, I am going to make that 4, 2. You just switch them. For the next point, negative 3, 2, you are just going to switch it to be 2, negative 3. You are literally just switching the 2. And finally, 4, 1 would be 1, 4. And then if you graph that on here, 4, 2 would be 1, 2, 3, 4, up 2. We have 2, negative 3, 1, 2, 3 down, and 1, positive 4. 1, 2, 3, 4. It still is the shape of a triangle, but this is its inverse. Okay? All right, so we didn't get through quite everything, but we got through a lot of things, okay? So we will try to finish this up some tomorrow. What I want you to know, homework number 2 is now due on Friday. So this is all about inverses, and I will get this uploaded later. I do already have the notes uploaded to today's date, okay?